Hi guys, welcome back to our channel. So today we are doing class 10 Maths NCERT chapter 8 exercise 8.3. It is one of the most crucial exercise of this chapter. So let's start with the question 1. We are asked to find trigonometric ratios sin A, secant A, tan A in terms of cot A. Before starting the question, we just need to know some basic formulas. That is, first one is sin square A plus cos square A is equals to 1. Second, cosecant square A is equals to 1 plus cot square A. And third is secant square A is equals to 1 plus tan square A. So let's start the question. Firstly, we need to find sin A. We know that sin A is opposite of cosecant A. So we can write this as 1 upon cosecant A. Now we know that cosecant square A is equals to 1 plus cot square A. But here we have cosecant A. So that we can write a variable x as x square under root also. And how? Because the under root and the square gets cancelled and we are left with the same number only. So can we write this cosecant as cosecant square A under root, because the term still remains the same. And from this we can put the value of cosecant square A as 1 plus cot square A. So it becomes cot square A plus 1 under root. So this is the value of sin A. Now we need to find secant A. We know from the formula that secant square A is equals to 1 plus tan square A. Okay, let's start from the formula only. We are given that secant square A is equals to 1 plus tan square A. Taking under root both sides. So I am taking the under root here as secant square A is equals to 1 plus tan square A. I have done nothing, just put under root on both sides. Just like in maths, we can add or subtract on the both sides. To balance the equation, we have just taken under root on both sides. Now we observe that we get it as square and under root. So can I write this as secant A? And this is 1 plus tan square A under root. Now tan is nothing but opposite of cot A. So I will write tan as 1 by cot A square. Because here we given as tan square A, so we write it as cot square A. Now taking the LCM, we get cot square A plus 1 under root cot square A whole root. Now I can separate the under roots, like I can write separately from the upper term and separately for the downward term. Now we see again we getting a square and under root, so we can cancel that and the answer will be cot square A plus 1 under root upon cot A. Third, we have to find is tan A in terms of cot A. And it's a very simple one because we know that tan opposite of cot A. So tan A is equals to 1 upon cot A. Lecture number 2. We have to write all trigonometric ratios of angle A in terms of secant A. So basically we have to write sin A, cos A, tan A, cosecant A in terms of secant A. Let's start with sin A first. From here we know that sin square A plus cos square A is equals to 1. As we know, sin square A plus cos square A is equals to 1. Sin square A as 1 minus cos square A. Now the square goes on the other side, it becomes under root. Or we can take under root on both sides. So we get it as sin square A under root is equals to 1 minus cos square A under root. Now the square and the under root gets cancelled. So we get as sin A is equals to 1 minus cos square A under root. We also know that cos is equals to 1 by secant A. So can I write this as 1 by secant square A? We had cos square A, so we have written secant square A. Taking the under root, taking LCM, we get it as secant square A minus 1 upon secant square A under root. Separating the under root for the upper and the lower term, we get it as secant square A minus 1 upon secant square A under root. Again the square and the under root gets cancelled. We get it as secant square A minus 1 under root upon secant A. Now people might ask that why are we cutting the square or under root? We should know that say if a term x is given, we can also write it as x square and under root. The term is still the same. We have just put the same time because under root is nothing but power 1 by 2. So 2 into 1 by 2 is just 1, which gives us x. Now let's find cos A, which is very easy because cos A is just the opposite of secant A. So cos A is equals to 1 by secant A. Moving on to tan A. Tan A is nothing but sin A upon cos A. We have just calculated the values of sin A and cos A, so let's just put us in this. We get as secant square A minus 1 upon secant A upon 1 by secant A. How we can write this? We know the property when A by B upon C by D is given, we can write it as A by B into D by C. That is, the numerator gets multiplied by the reciprocal or denominator. Okay, let me just write it that way. So this would be secant square A minus 1 upon secant A multiplied by secant A upon 1. So secant A and secant A gets cancelled. We get it as secant square A minus 1 under root. We could have done this directly also from this identity. How? We could have written tan square A is equal to secant square A minus 1 under root, which is what we are getting. Next we get is to cot A. Now cot A is just opposite of tan A. So cot A is equals to 1 by tan A. So that would give us 1 upon secant square A minus 1. And the last one is cosecant A. Cosecant A is opposite of sin A. And what was sin A? This. So let us just write it 1 upon secant square A minus 1 upon secant A. Now we know that A by B by C is nothing but A into C by B. So let me just write it that way. So it comes as 1 into secant square A minus 1 into secant A. And that is our answer. Secant A upon secant square A minus 1. Let's start with third question now. We need to find the correct option out of the 4 given to us, and we also need to justify why we have chosen that answer. So the first part given is 9 secant square minus tan square A. Let's solve this. 9 secant A minus 9 tan square A. We see that 9 is common in both terms, so can I just take it common? So we get as secant square A minus tan square A. We also know identity that secant square A is equals to 1 plus tan square A. So if I take tan square A at this side, we get as secant square A minus tan square A equals to 1. This value of A, so putting value of A in equation 1, we get as 9 into 1. So the answer is 9. So the correct option is B. Now coming to second part, we are given with 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta, and we are given with 4 answers. That I don't think we can put any identity to do this. So what we can do is let's just convert into sin theta cos theta terms, so it becomes simpler for us to solve it. Now we know tan theta is sin theta by cos theta. So 1 by sin theta upon cos theta. Similarly, secant theta is nothing but 1 by cos theta. Solving the second bracket, we get as 1 plus cot theta. So cot theta is just the opposite of tan theta, so it is going to be 1 plus cos theta upon sin theta. And cosecant theta is 1 by sin theta. Now let's take the LCM in both the brackets. Here we get it as cos theta is a common, so here we get as cos theta plus sin theta plus 1 upon cos theta. Here we get the LCM as sin theta. So here it is going to be sin theta plus cos theta minus 1 upon sin theta. Now if you observe, does this look like an identity of a square minus b? How? If this, we consider this as a and this as b, and so this is a and this is b. So we see that we are getting here as a plus b into a minus b. So I can write this as a square minus b square. How I can write this as cos theta plus sin theta whole square minus 1 ka square on cos theta into sin theta. Cos theta into sin theta. We will write it here as using a minus b into a plus b gives us a square minus b square. It is as a plus b ka whole square, right, where a is cos theta and b is sin theta. A plus b whole square is equals to a square plus b square minus 2ab. Sorry, plus 2ab because we have plus in putting identity we get as cos square theta plus sin square theta plus 2 into cos theta sin theta minus 1 because square of 1 is just 1 upon cos theta sin theta. So we know the identity that cos square theta plus sin square theta is nothing but 1. So let's just put the value 1 plus 2 cos theta sin theta minus 1 upon cos theta sin theta. Now the 1 gets cancelled with each other. We get as 2 cos theta sin theta upon cos theta sin theta. Now the terms are same and they also get cancelled because numerator and denominator are same. So we get our answer as 2. So the correct option is C. Now moving to third part, observe that there is no identity that can be applied to it. So let's just convert it into sin and cos theta for simpler terms. So secant is 1 by cos A and tan is sin A by cos A into 1 minus sin A. Right? Taking the LCM, we get cos A only. We get 1 plus sin A upon cos A into 1 minus sin A. This again becomes the identity of a square minus b square. How? A plus b into a minus b is equals to a square minus b square. So I write this as 1 square minus sin square a upon cos a. This comes as 1 minus sin square a upon cos a. Now we know the identity that cos square a plus sin square a is equals to 1. So can I write the value of cos square a from here as 1 minus sin square a? Write 1 minus sin square a here as cos square a upon cos a. Cos a, 1 cos a gets cancelled and we get our answer as cos a. So the correct option is D. Now coming to fourth question, we see that there is like a direct relationship between the basic identities. How? We know that secant square a is equals to 1 plus tan square a and cosecant square a is equals to 1 plus cot square a. So using these, our equation becomes secant square a upon cosecant square a. Putting these into sine and cos, secant is nothing but opposite of cos. We write it as cos square a because we have secant square a. Similarly, we write it as sine square a because we have cosecant square a. We know a by b upon c by d is nothing but a by b into d by c. That is, the numerator gets multiplied with the reciprocal of denominator. So writing it that way is 1 by cos square a into sin square a upon 1. So what we get as sin square a upon cos square a. So that sin by cos is tan a. So sin square a by cos square a is tan square a. And that is our answer. So the correct option is D. So now let's move to question 4, where we have to prove the following identities and where the angles given are acute angles. So let's start with the first part. We are given that we have to prove that cosecant theta minus cot theta square is equals to 1 minus cos theta upon 1 plus cos theta. So let's start from left hand side and reach the right hand side. We know that we need the answer in terms of cos. So let's convert these cosecant and cot in terms of sine and cos theta. We can write this cosecant theta as 1 upon sine theta and cot theta as cos theta upon sin theta whole square, right, as we are given. Now let's take the LCM. We get sin theta, and in numerator we get 1 minus cos theta whole square. Now let's separate the square on numerator and denominator. We get 1 minus cos theta whole square upon sin square theta. Now this is nothing but a minus b square, which is basically a minus b into a minus b. That is square of one term. So we can write this as 1 minus cos theta into 1 minus cos theta upon sin square theta. Right. Now we also know that cos square theta plus sin square theta is equals to 1. From here I can derive that sin square theta is equals to 1 minus cos square theta. So putting value of sin square theta here, we get 1 plus cos theta, 1 minus cos theta into 1 minus cos theta upon 1 minus cos square theta. This is like 1 square is 1 only. So we can write it as 1 square minus cos square theta. So we can write the term as 1 minus cos theta into 1 minus cos theta upon 1 plus cos theta into 1 minus cos theta by using a square minus b square is equals to a plus b into a minus b. Now here we see that 1 minus cos theta is common in numerator as well as denominator. So we can cancel the term. What do we get? 1 minus cos theta upon 1 plus cos theta, which is equals to our right hand side. Right? Now in second part we are given with this, and we have to prove that cos a upon plus 1 plus sin a plus 1 plus sin a upon cos a is equals to 2 secant a. So let's start from left hand side. Let's take the LCM. We get it as 1 plus sin a into cos a. Now we would need to multiply this numerator with cos a, because in denominator we just have 1 plus sin a. So we multiply cos a into cos a multiplied by cos a plus, and here we would have to multiply with 1 plus sin a because we just have cos a in denominator. So 1 plus sin a into 1 plus sin a. So this is gonna be cos square a plus 1 plus sin a whole square upon 1 plus sin a into cos a. Now we can open this using identity a plus b square is equals to a square plus b square plus 2ab. So let's just use that, which is cos square a plus 1 square plus sin square a plus 2 into 1 into sin a upon 1 plus sin a into cos a using a plus b whole square, which is equals to a square plus b square plus 2ab. Now solving this, we also know an identity which is cos square a plus sin square a is equals to 1. So here we can say this term and this term would equal 1, and square of 1 is 1 only. So 1 plus 1 plus 2 into 1 into sin a gives us 2 sin a upon 1 plus sin a into cos a. So this is gonna be 2 plus 2 sin a 1 plus sin a into cos a. Now I can take 2 common out of here. So what I will get is 2 1 plus sin a upon 1 plus sin a into cos a. Now we have 1 plus sin a common in numerator and denominator, so they both get cancelled with each other, and we get the answer as 2 by cos a, and 1 by cos a is equals to sec a. So 2 sec a is the answer, which is equals to RHS. Move on to third part of question 4. Let's take the left hand side first. Let's convert the left hand side into sin and cos theta terms to make it simpler for us. So we can write tan theta as sin theta by cos theta 1 minus cot theta, which is cos theta by sin theta. Similarly, in this term, cot theta can be written as cos theta by sin theta, and tan theta is 1 minus sin theta by cos theta. Taking LCM in both the terms, we get sin theta by cos theta upon sin theta minus cos theta upon sin theta, plus similarly here cos theta upon sin theta upon cos theta minus sin theta upon cos theta. Now, so we know that A by B upon C by T is nothing but A by B into D by C. That is, numerator gets multiplied by reciprocal of denominator. So let's just apply that here. So it's going to be sin theta cos theta multiplied by sin theta upon sin theta minus cos theta, plus cos theta upon sin theta into cos theta upon में cos theta minus sin theta. A by B upon C by D is equals to A by B into D by C, right? So the numerator here becomes sin square theta upon sin theta minus cos theta into cos theta, right? And the other term becomes cos square theta upon sin theta into into cos theta minus sin theta. Now, if we notice that this term is common in the denominator, it's just that the sign is different. So if I take minus common here, the term would interchange, like the minus sign would become positive and the positive would become negative. Let's do that. So it's going to be sin square theta upon में sin theta minus cos theta into cos theta plus cos square theta. We'll take the minus out. It's going to be sin theta into sin theta minus cos theta. Now let's take the LCM. This term is common, so this is just going to get multiplied by sin theta and this is going to get multiplied by cos theta, right? So this will become sin cube theta minus cos cube theta upon sin theta minus cos theta into sin theta cos theta. Now in class 9 we have studied the formula of a cube minus b. Let's apply that. And what is a cube minus b cube? A cube minus b cube is nothing a minus b into a square plus b square plus ab. So let's just apply that here. It's going to be sin theta minus cos theta into sin square theta plus cos square theta plus sin theta into cos theta and divided by sin theta minus cos theta into sin theta cos theta. Right? Now we see that these terms are same in numerator as well as denominator, so these get cancelled. Now, and we also know that sin square theta plus cos square theta is nothing but 1. So we can write that as 1 plus sin theta cos theta upon sin theta cos theta, right? Now when we separate these terms, we get 1 upon sin theta cos theta and sin theta cos theta upon sin theta cos theta, right? So this becomes 1 because it gets cancelled out, so this is our 1, and now we separate this also. It's going to be 1 by sin theta into 1 by cos theta, and 1 by sin theta is cosecant theta, 1 by cos theta is secant theta plus 1, and this is equals to our RHS. Now let's start the fourth part. Here in the book itself we are given that we need to solve LHS and RHS separately. So let's start with LHS first. We can write secant in terms of cos A. So it's going to be 1 plus 1 by cos A upon 1 by cos A. Taking LCM in the numerator, we get cos A plus 1 upon cos A divided by 1 by cos A. Now we know A by B upon C by D is equals to A by B into D by C. Therefore, cos A plus 1 upon cos A would be is equals to cos A by 1. This becomes the equation. Cos A gets cancelled. So we get the answer as cos A plus 1. Now let's solve the RHS. Okay. We have sin square A upon 1 minus cos A. We know cos square A plus sin square A is equals to 1. So putting the value of sin square A from here to here, that is sin square A is equals to 1 minus cos square A. Therefore, our equation becomes 1 minus cos square A upon 1 minus cos A, right? Now, square of 1 is 1 only, so we can write this as this, and we can write this 1 square minus cos square A is 1 minus cos A into 1 plus cos A upon 1 minus cos A. How? Using A square minus B square, which is equals to A minus B into A plus B. Right now we have the same term in numerator as well as denominator, so these gets cancelled. So our answer comes as to be 1 plus cos A, which is equals to LHS. Now moving to next part, we see that we need to prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equals to cosecant A plus cot A. Now we see that there is no term in LHS or no identity that can be put directly in the LHS to prove that it is equals to RHS. So what we do is we start by converting it into terms of cosecant and cot, and how we can do that is that we'll divide all the terms by sin A. Divide all the terms by sin A, right? Let's do that. So we'll get it as cos A upon sin A minus sin A upon sin A plus 1 by sin A. Now similarly in the denominator we get cos A upon sin A plus sin A upon sin A minus 1 by sin A. Next up we see cos A by sin A is cot A. Sin A by sin A is just 1, and 1 by sin A is going to be cosecant A. Similarly, in the denominator, this becomes cot A, this becomes 1 again, and this becomes cosecant A. Now, we also know that cosecant square A is nothing but 1 plus cot square A, right? So, from here, I can write that cosecant square A minus cot square A is equals to 1. So, let's put the value of 1 in the numerator this. We get cot A plus cosecant A minus cosecant square A minus cot square A, right? We're getting that upon denominator will remain the same, that is cot A minus cosecant A plus 1. Now I have cot A plus cosecant A, and here we have is A square minus B square. So let us divide that. That is going to be A minus B cosecant A minus cot A into A plus B, and the denominator will remain same, that is cot A plus 1 minus cosec A. Here we have used because A square minus B square is equals to A minus B into A plus B. Now we see that cot A plus cosecant A is common in both the terms, so we can take that as common. So cot A plus cosec A, we have taken common, so here just remains 1. So 1 minus, we are left with cosecant A minus cot A. So it's gonna be 1 minus cosecant A minus cot A divided by cot A minus cosecant A plus 1. Now this is gonna be cot A plus cosecant A into, the minus sign will change the sign inside also, so it's going to be 1 minus cosec A plus cot A, and in denominator we already have cot A minus cosecant A plus 1. We see the term in numerator and denominator both are same, so they get cancelled out, and we get the answer as cot A plus cosecant A, which is equals to RHS. Moving on to the next part, consider the LHS first. What we're going to do is we're going to rationalize the LHS. That is, we're going to multiply the numerator as well as denominator by under root 1 plus sine A. So we get 1 plus sine A whole square, right? Because two terms of same are multiplied. And here we get as 1 minus sine A into 1 plus sine A. What we are getting. So here we see that the under root and the square gets cancelled and we get the term itself, which is 1 plus sine A. And down there we get as 1 square minus sine square A under root. Why? Because A minus B into A plus B is equals to A square minus B square. Right? Now we know that cos square plus sine square A is equals to 1. So 1 minus sine square A is equals to cos square A, right? Therefore, our equation becomes as 1 plus sine A upon cos square A under root. Similarly, again the under root and square gets cos, so answer becomes 1 plus sine A upon cos A. Let's separate the numerator and denominator. So it's gonna be 1 by cos A plus sine A by cos A. So 1 by cos A is nothing but secant A, and sine A by cos A is nothing but tan A, which is equals to RHS. Now in next part we have to prove that sine theta minus 2 sine cube theta is upon 2 cos cube theta minus cos theta is equals to tan theta. So let's start with LHS first, and what we're going to do is we're going to take sine theta common in numerator and cos theta common in denominator. So we are taking sine theta as common, so here we are left with just 1 and here we are left with 2 sine square theta. Similarly in the denominator we take cos theta as common and we get here as 2 cos square theta minus 1. We know sine square theta plus cos square theta is equals to 1. So let's put the value of 1 in equation. We get sine theta into sine square theta plus cos square theta minus 2 sine square theta upon cos theta into 2 cos square theta minus sine square theta plus cos square theta. So sine theta upon sine square theta plus cos square theta minus 2 sine square theta. So we can write this as cos square theta minus sine square theta, right? Because we have 2 sine theta and 1 sine theta. So minus 2 plus 1 is minus 1. So cos square theta minus sine square theta, right? In the denominator we have cos theta brackets 2 cos square theta minus sine square theta minus cos square theta. So in denominator we get, in the denominator what we get is 2 cos square theta minus cos square theta is cos square theta and minus sine square theta. So these both terms are same in numerator and denominator, so they get cancelled to each other and we get that as sine theta by cos theta, which is equals to tan theta, which is equals to RHS. In the 8th part, let's start with LHS and try to reach RHS. So firstly we are given with sine A plus cosecant A whole square plus cos A plus secant A whole square. We can directly apply the identity of A plus B square, which is A square plus B square plus 2AB. Just apply it, it's going to be sine square A plus cosecant square A plus 2 into sine A into cosecant A. Similarly, here we'll have as cos square A plus secant square A plus 2 cos A into secant A. we can collaborate this and this as 1. So let me write it together first. Sine square a plus cos square a. Now we also know that cosecant square a is nothing but 1 plus cot square a. So I have written because cosecant square a is equals to 1 plus cot square a. Right. Now this is 2 sine a, and we know cosecant is just the opposite of sine, so we can write this as sine a right only. This gets cancelled, we get the 2 as answer. Cos a we have already written it here. Then we have a secant square. I can write secant square as 1 plus tan square a, because secant square a is equals to 1 plus tan square a, right? And here I get as 2 into cos a, and we know secant a is just 1 by cos a, so I can write this as 1 by cos a only, and this gets cancelled and I get 2 term here. So sin a plus cos a is 1. This we have is 1 plus cot a, so 1 plus cot square a. Here we are just left with 2. Here we are left with 1 plus tan square a. And here we are just left with 2. So adding all the terms, you get 1, 2, 1, 2, 4, 5, 7. Get as 7 plus cot square a plus tan square a, which is equals to RHS. So let's start ninth part now. Let's start with LHS first. We are given with cosecant a minus sin a into secant a minus cos a. So let's convert cosecant and secant into sin and cos term first. So cosecant is nothing but 1 by sin a minus sin a, and secant a is nothing but 1 by cos a. Now let's take the LCM in both the equation. We get sin a. This is gonna be 1 minus sin square a, and this is gonna be 1 minus cos square a upon cos a. Now we know that sine square a plus cos square a is equals to 1. So from here I can write that 1 minus cos square a is nothing but sine square a. It's going to be sine square a upon cos a. And 1 minus sine square a is nothing but cos square a. You can write this as cos a by sine a. Now this cancelled with this and this is cancelled with this. What I get is cos a into sine a. Let's solve the RHS separately. Let's convert the tan and cot a in sine and cos theta terms. Tan a can be written as sine a by cos a, and cot can be written as cos a by sine a. Let's take LCM in the denominator. We get sine square a plus cos square a into cos a sine a. Because here sine a is going to get multiplied by sine a and cos a is going to get multiplied by cos a. And we know that sine square a plus cos square a is nothing but 1. So what we can write as 1 upon cos a into sine a. And we know a upon b by c is nothing but a by b into c. Here it becomes 1 into cos a sine a by 1, which is equals to cos a sine a, and which is equals to LHS. Moving on to the last question of the exercise and the chapter, we would have to do it in two ways. First, we'll prove this is equals to this and this is equals to this. So consider this LHS. Firstly, we are considering this. So 1 plus tan square a upon 1 plus cot square a. Let's convert tan and cot in terms of sine and cos. Sin is going to be sine by cos. It's going to be sine square a and cos square a. Right? And here it's going to be 1 plus cos square a upon sine square a. Taking LCM in both numerator and denominator, we get cos square a plus sine square a upon cos square a upon sine square a plus cos square a upon sine square a. Right? Now we know cos square a plus sine square a is equals to 1. So putting this value here, we get 1 upon cos square a upon 1 upon sine square a. We also know that a by b upon c by d is nothing but a by b into d by c. So this is going to be 1 by cos square a into sine square a by 1. So this becomes sine square A by cos square A, which is equals to tan square A, which is equals to RHS. Moving on to this, we have 1 minus tan A upon 1 minus cot A whole square. Now I can write cot A as 1 by tan A. So it's going to be 1 minus tan A by 1 minus 1 by tan A का whole square. Taking the LCM in the denominator, I get tan A minus 1 upon tan A. Right? And we know that A upon B by C is nothing but A by B into C. It's going to be 1 minus tan A, we have a whole square here, upon tan A minus 1 into tan A is a whole square. Now, if I take minus common, the signs would change inside the bracket. So, I'll keep it as 1 minus tan A upon 1 minus tan A. I've taken the minus common here into tan A, right? And we have a whole square. So, these terms are same, so they get cut. And the square of anything even negative is positive. So, what we get it as tan square A, which is equals to RHS. Thank you for watching our video. If you would like to know the answers for exercise 8.1 or 8.2, you can visit the other videos on our channel. Any other question or doubt, you can just pin us your questions in the comment section. Thank you.